Okay, good evening. So today we will discuss the past paper questions. Okay, students. So I have sent you this nice past paper compilation, and we have to prioritize the new questions instead of old questions. We have to prioritize the new questions. Okay, so I will start from somewhere 26. Okay, or else 20, just to be to be to do more questions. Still, we will have. Okay, we will start from 20. Okay, so you have tried, right? Can you raise your hands if you have tried the MCQs? Raise your hands if you have tried the MCQs. Only one person. Tanujan, you didn't try any MCQs.
Yes, sir.
You tried. Okay. All right. I think you tried it. All of you tried. I have given some homework, so I'll first discuss those. I gave you some graph questions, right? Where are the questions? I gave you an ST graph like this. I asked you to convert it into VT graph. Okay. I made sure that nowhere the line is flat. If it is flat, it will be called zero gradient, which means velocity is zero. So you need to be careful. See, here it is an acute angle, right? Acute angle. But if you see it is decreasing, but it doesn't become zero, and then it increases. So when it is acute angle, theta less than 90, the gradient is positive, and when the angle increases, gradient increases. Then when the angle decreases, the gradient decreases, which means tan theta. Here the angle decreases and then increases. So which means gradient will decrease and then increase without reaching zero. So it will be like this. Okay? Yeah. Then I gave you a question like this. A ball is thrown, okay? So we will make a line. So along this line, the ball is thrown. After the ball is thrown, after 2 seconds, another ball is thrown. And then at some point, they are going to collide, which means this will go to the highest point and then come back. And this will go straightly and collide with the previously thrown ball. So this is the point of collision. So I asked you, what is the distance from the topmost point to the point of collision? Didn't I? Or H. Right? That was the question. So anybody found the answer? The delay is 2 seconds.
5 meter.
Saying 5 meter. Okay, good. How did you get to the answers? Did you use equations?
Relative velocity.
You use relative velocity. Okay. So I'll tell you an MCQ method. Okay. This was an actual question in 1987 or something. So just see this first ball, it goes to the highest point and come back, right? It goes to the highest point and then only comes back. So from here, it goes up and comes back. So this is the extra motion that the first ball has performed compared to this. They both will have identical pathways and identical values for velocities at every level. For example, in the middle of the journey, both will have same velocity. So their paths, all of the things are, identical. The only thing is, the first guy is 2 seconds before the second guy. So this is the extra motion that the first ball has performed. We named it X and the second ball Y. So now tell me, what is the time taken for this part of the motion for the ball X? Guys, why is it performing an extra motion? Because this is thrown first, right? So that's the reason why it's performing some extra motion. So that extra motion is for how long?
2 seconds.
Exactly 2 seconds. So this part of the motion will take 2 seconds. So if you divide it, going up will take 1 second. Going down before collision will take 1 second. Do you agree with it? Now from the highest point until the collision, from the highest point the velocity is 0. Until the collision is 1 second. So you can use downwards, the acceleration also. So downwards, st is equal to ut plus half at square. S is the question, u is 0 because it starts from rest. Half a will be downwards 10, t square will be 1 second. So the correct answer is 5 meter. Okay. What is the velocity when they collide?
10 meter second minus 1.
Yeah, 10 meter second minus 1. Because from rest, it is moving for 1 second. Gravitational acceleration is 10, so therefore it will gain 10 ms minus 1 during that period. Now I will ask you another question. Are these things, this 5 meter, the height from the highest point, and the velocity while colliding, does it depend on the initial velocity of the balls? No, it doesn't depend on the initial velocity of the balls. It depends only on this delay. Students, what I am talking about is a possible true false, what do you call it, statement question that can appear in your past paper. Sorry, in your final paper. Because that's how they make questions. Okay. So this is already there in past papers. Very, very old past paper questions come in new form. Sometimes those questions are more difficult than the new questions. But new questions, will be difficult for students, put it into past papers. So therefore, always be familiar with the questions that came in your past papers. Okay. All right. So I will discuss your questions now. Okay. So just stay with me. Okay. Listen to me carefully, and at the end of the class, in between you can ask doubts. At the end of the class, also I will be clarifying your doubts. Okay. Half of the class will be using the whiteboard due to the less charge I am doing in the iPad. Now, 20th one. Now, a stone is thrown at a certain angle with the horizontal in the direction as shown by the arrow. So, like this. If the R resistance is ignored, which of the following velocity time graphs best represent the variation of Vx? Vx means the horizontal component of the velocity with t, and Vy, which is the vertical component of the velocity with time. Now, it's a projectile motion. Projectile motion has two components, vertical and horizontal. When it comes to vertical motion, it is a free fall under the gravity. So here the acceleration is g. Acceleration is g. But horizontally, there is no force. When there is no resultant force in your equation, F is equal to ma, if force is not there, A cannot be there. So therefore, here acceleration is 0. So horizontal velocity doesn't change. So this is the graph of horizontal. Vertical, it will be a motion under gravity. It is a uniform acceleration or deceleration you will have. Gradually, the upward velocity in a free fall will gradually uniformly decrease, attain zero velocity at the end, and then it will perform the motion in the opposite direction for the last half. So the direction is switched. It is reversed. So therefore, initially in one direction, uniform deceleration. In the other direction, uniform acceleration. So correct answer is this. Okay, so you know what is the answer here. Any questions? Okay. Now a ball B is projected horizontally, shown. Question number 21. Horizontally with speed u. And a ball A is dropped vertically from rest at the same instance as shown in the figure. Which of the following statements is true? Neglect AR resistance. Okay, now they're asking which one reaches the ground first and which one will have the higher speed. So when they say speed, you don't consider the direction. Actually, they will have opposite directions. If you say velocity, you can't compare two velocities that are in different directions. So that's why they say speed. So they're focusing only on the magnitude of it, not the direction. Now, first, look at the time. What do you think? Huh?
Same
As a
time.
student, as a student who has done adequate practice in projectile motion, what can you say?
Same time.
Yes, same time. Because ball A is just dropped, so no initial velocity vertically. Ball B is also thrown horizontally, so you're not giving any vertical initial velocity. So when you use downwards, S is equal to ut plus half at squared. Okay. So ut is 0 for both. In this direction, they will have same acceleration, which is g. Okay. And same distance they have to travel. So t should be same, right? Same vertical height they have to travel. A is same, so t should be same. So what you do is you have to write this explanation in your whatever the explanation note you are making. You should have a complete note for every chapter. Okay, so what you do is you say it's 0, so S is equal to half 80 square. What you mark is same. A, G, same. So T should be same. This is the explanation you write. It's a number, no, it's same. Half is a constant, so it's same. So like that. Okay. So same time. What about the speeds?
B have higher speed.
Why is that?
In the vertical component, both will have the same velocity. But B have
Exactly. Good. So vertically, they have same time for the motion. Initial velocity is 0. So if the time is same, according to the equation, V is equal to U plus AT. Time is same. Initial velocity is 0. A is same. So both will have same vertical final velocity. Okay, note it down. They will have same vertical final velocity. But when B reaches the ground, come on. When B reaches the ground, it will have an additional horizontal velocity also, in addition to the vertical velocity. So the resultant will be greater when compared to A. Okay? Resultant will be greater when compared to A. Okay, you will use the Pythagoras to find the final velocity. But you know, in Pythagoras, the hypotenuse is always greater than the adjacent sides, right? So that knowledge you have. So you know for B, definitely the velocity will be greater than, speed will be greater than A. So you know what the answer is. The correct answer is fifth one. Okay. Now question number 22. Figure shows displacement versus time curve for a motion of a particle. Consider the following statements made about this motion. During period t to t1, the particle moves at a constant acceleration, and during t2 to t3, moves with constant velocity. Note the thing, it's a displacement time graph. Okay, they test you in a simple thing. Can you see? So now what you know is, what does a displacement time graph tell you? What does the gradient of the graph tell you? Yeah,
velocity.
velocity. What does the area under the graph tell you? You should answer what? It's meaningless. The area under the graph is meaningless. Okay. So you guys remain silent. Good for you. Okay. Now, if we draw a velocity time graph, just for the explanation purpose, until t1, you see it has a positive, it's acute angle, so positive constant gradient. So therefore, it will be like this. And from T1 to, after T2 until T3, zero gradient. So it remains like this. And after T3, it is negative. Okay, it should be like this. T3 should become here. The graph is a little shifted, or maybe the line is shifted towards the left side. Whatever until T3 only it is at rest. After that, it has a negative gradient that is also constant. So it should come like this. And velocity time graph, its gradient will give you the acceleration. Here, this segment has no gradient, this segment has no gradient, both are zero. So, there is no acceleration during the whole motion. So, therefore, this statement is wrong. Then B, particle comes to rest at time T4. No, actually at T4, it has an angle. At that moment, because of the angle, it is definitely a non-zero velocity. So, it's false. It has a velocity. Okay, because the graph is ending there, it doesn't mean the gradient is zero. Okay. C, during the time period T0 to T4, total distance traveled by the particle is equal to the area under the ST curve. That is false. I told you it's meaningless. It's absolutely meaningless. Some students think it gives the distance. I don't know. It never gives the distance. It's a wrong idea that they have. So all are false. Fifth answer. Do you have any questions? Okay. A person simultaneously drops an object and throws another object vertically downwards from a certain height. So dropping is from initial zero velocity. Throwing is with the initial velocity. So dropping is initial velocity is 0. V is equal to U is equal to something. U is greater than 0. So this is throwing initial velocity. This is dropping. Now for set height, which of the following graphs best represents the velocity time curves for two objects? Now curve A represents the dropped one, so initial velocity should be 0, and B represents the thrown object, right? Yeah. Which graph?
First one.
Yes. So when something is freely falling, when air drag is not there, whatever the object you have will experience a force of magnitude mg. When you use downwards F is equal to ma for the object, for F you put mg equal to ma. You can chop m's, so A will be equal to g. For any object, A will be equal to g in downwards direction. So in velocity time graph, the acceleration should be same because it's g. When acceleration is same, the angle that it makes with the x-axis should be same, isn't it? The angle should be same. So therefore, the graphs should be parallel. You understand? The graphs should be parallel. Okay, so other graphs are all wrong. Only the first one. Okay. Okay. So now, one question came. In old past papers, they put a statement like when the object is thrown upwards with a very high velocity, it can overcome the gravitational deceleration. Is that a correct statement?
Wrong.
No. Once you throw, after that, nothing is touching it to provide additional force to overcome the gravity. If you are constantly, like Superman carrying some heavy object upwards, if you don't have to be carrying heavy objects, whatever the object, if you are going to give a constant upwards force, then you can produce an acceleration. You can overcome the gravity. But whatever the speed you give, right, whatever the speed you give initially, you will never overcome the gravity when it is out of your hands. Okay, so that statement was wrong. The old question. Okay, so correct answer is first one. So here, what do you write in your explanation note? You write graphs should be parallel because same angle should be made with the x-axis. You write with those words, okay? That will improve your understanding of physics. Usually the way you express will tell how you have understood the lessons. Some people will say, okay, this is the answer, but I don't know how to explain it. No, it's not like that. When you are able to explain, you're always superior than a person who cannot explain. They can be a bad explainer, but when you actually dig in, they should come up with the right explanation. If they don't know it, it means that it's incomplete, right? The knowledge. Now this one, velocity time curve for the motion of particle is shown in the figure. The corresponding displacement time curve. So here the velocity decreases and comes to 0 in plus. So here the gradient will decrease and become 0, right? So which one? This one is fine.
Fifth.
This one wrong. Others are fine. Yeah?
Fifth.
Yeah. And the middle segment is 0 velocity, which means graph is parallel to the x-axis. That's what you have to write. Graph should be parallel to the x-axis. You don't see that here. It's all of a sudden the displacement will not change. Displacement, guys, always. It's a position, right? According to this graph, what happened is the object vanished from the initial point and it appeared in the initial starting point like magic. These graphs are never possible for an ST graph. Okay. So for some time it should be 0 and then positive gradient should increase. So therefore, fifth answer. You can see the angle increasing. It should be flat. There is no break like it is shown. Here there is a small break now here. That should not be there. Okay. Photographs of an object that starts falling freely from rest at t is equal to 0 are taken by the camera. First at t is equal to 0 and thereafter at the end of each second. So at the end of each second, it's showing the positions and it is the displacement can be seen from the scale. So it's just a question for you to calculate the displacement at the end of each second. It's not that hard. Okay, you have to just substitute. It is falling from 0 velocity, right? Freely. S is equal to ut0, so half at squared. Half a is 10 and t squared will be 1 squared for the first second, so it will be 5 meter. Second, 10 and you put 2 here, so it will be 20 and that gives you the correct answer. Third one. So fourth one, no? Fourth one. Okay, so this is a very easy question. Okay, 26. It came as the 40th question, I guess, in 2012. So you can see how easy the questions are. Okay. The variation of velocity u with time t, particle is shown in the figure. The corresponding displacement time curve is best represented by. Okay. So here it is velocity. So it explains the gradient of the displacement time graph. So here plus and increases. So gradient will be plus and it should increase. So what are the graphs that will not come as your answer? Hello, can you hear me?
Yes.
Yeah. What are the answers that cannot come? It's the method of elimination. Yeah.
First answer, third
Fourth
answer,
answer.
fourth answer.
Yeah. First one come, third one come, fourth one come, because those are all straight lines, right? So only you are left with second and the fifth. And then it reaches a constant velocity, which means the gradient should be constant. What do you see in the second one? Is it a curve?
Yes.
Yeah, it is a curve. Come on, it's a curve. It is seen here. And the gradient decreases. And when you see a point like this, it is flat. The graph is parallel to the x-axis. Okay, so therefore, you have to say the velocity is 0, but that's not happening in the actual graph. So that is also not one of the answers. So the answer is there with the second segment itself. You don't have to look at the rest. So it's there. Okay. Now here this segment, the positive gradient should decrease and the velocity is becoming 0. Here you can see it is becoming flat, no? So it's becoming 0. And then in negatives it increases, nicely shown. Then in negatives it decreases, nicely shown, and becomes 0, and it is becoming flat here. So I'm asking you, why is the graph not like this? Like I'm drawing in the, why can't the displacement also touch the 0?
The area on the positives and negative sides of the velocity time graph should be equal.
Excellent. Yes. So this area gives you the velocity displacement in the first positive direction, and this area will give you the displacement in the opposite direction. This is obviously greater when you look at it. So positive displacement is greater than the negative displacement. So at the end of the motion, there is a net displacement. Resultant displacement is there, which is a non-zero value. So therefore, fifth answer is should come with a final displacement here. So they can confuse you by giving gradient wise correct graph, but magnitude of the displacement wise wrong graph. So you need to figure out. Okay. The charging, not that good. Yeah. Next question, I think same projectile motion. 28th question. So it's a bit, but you have studied a SHM, simple harmonic motion. So I can explain that to you. A ball is dropped from a height of 1.8 meter into a rigid surface. The collision between the ball and the surface is perfectly elastic. If the ball continues to bounce on the surface, the motion of the ball is, so you know, it will always reach 1.8 and it will go back, hit the ground, come back and reach 1.8 because the motion collision is perfectly elastic. What is perfectly elastic collision?
No energy loss when it
Yeah, when there is no mechanical energy loss. Whatever the speed it hits the ground with is there when it returns from the ground. So there is no mechanical, or you can say kinetic energy loss. Okay, so that is your perfectly elastic collisions. Now they're saying whether it's simple harmonic motion, whether it's a periodic motion. So what is a periodic motion? When a same kind of motion within same period of time, when it recurs, it is periodic motion. Actually, I studied this in when I was in grade 6. I don't know whether, I mean, they definitely changed the syllabus, but they taught us what is a recurrent phenomena, non-recurrent phenomena. Okay, they explained all those things to us. And they also explained a periodic motion. Periodic motion is recurring within same period of time. Identical motion should be there. So what is the period? Period is the time duration for a complete cycle of periodic motion, which means same position should be attained or same kind of motion should be attained twice consecutively at the start and the end. That is what you call a period. And then the time taken for it is periodic motion. So how does it differ from oscillation? Anybody? What is oscillation? Is oscillation a periodic motion? Yes. Oscillation is always a periodic motion. But are all the periodic motions oscillations? No. Oscillation should always have a equilibrium point. Okay. And the motion should be back and forth. There should be a central kind of point, which is called the center of oscillation. And there should be a back and forth motion. That is oscillation. Oscillation is that. Simple harmonic motion is a special kind of oscillation where, complete the sentence please. Simple harmonic motion is a special type of oscillation in which, yes, come on, acceleration is directly proportional to the displacement and always towards the center of the oscillation. So that needs an equation proof to say something is a SHM. It cannot just be an oscillation. Okay, you understand? Oscillations, not all the oscillations are SHM also. In some oscillations, A can be directly proportional to minus x squared. That will also be back and forth. We'll have a center, but will be directly proportional to the squared. Not exactly your simple harmonic motion. So it's not a simple harmonic motion that you see in a perfectly elastic collision that is recurring. U is 0, comes down, hits the ground, and goes up. So does it have an equilibrium point? No. At equilibrium point, the force, resultant force should be 0. Here there is nowhere you find a zero resultant force. Always the resultant force is mg, right? Not when it's hitting the ground. When it hits the ground, it's different. So yeah, so it doesn't have a center of oscillation. So it's periodic. The periodic time is time taken from here and then coming back to the old position. So if you calculate the time, it becomes what? Tell me. You guys have to save your time, otherwise. 0.64, one half, and the rest. Another 0.6, so it's 1.2. Okay. Third answer. I think if you can do this one, constant. So constant gradient, then positive gradient decreases becoming 0 and negative gradient increases and negative gradient constant. So the correct answer would be first one. Okay. 30th I have explained. This one,
Second answer.
positions, positions of 3 motor car, 1, 2, and 3, traveling along 3 parallel straight lanes, roads, at time t is equal to 0 and t is equal to t naught are shown in the figure A. And the corresponding velocity Vt graphs are shown in the figure B. Here. The situation shown in the figure A could have happened only if the areas in the graphs satisfy the conditions. So what is the idea here? I'm asking you these questions assuming that you have tried.
The area of the graph should be same.
Exactly. In this diagram, you can come to only one conclusion. At the starting point and ending point, they are at the same position, means they have traveled same distances or displacements. Agree? They have traveled same displacement. So therefore, you have to have same area under the graphs. Okay. So here, come on. Right. It is a question where you have to like go through the answers and then come to the answer. Okay, because it's very difficult to just to say straight away that this should be the condition. So you have to go through the answers. Okay, so I'm going to color. Look at the graph BF for the second graph. It's like in the middle, right? So it will be traveling a distance this. Okay, but what you say is this T D G. This quadrilateral. It's a quadrilateral, no? Both sides. Is identical for all the things. And they will have some additional segments, right? They have some additional segments for them. For example, this graph will have this, and this. This graph will have this and this. This graph has this and this. Okay, understood. So you have to just compare these because this is common now. So you have to just compare these. Okay. So what is the condition? Considering second and the first graph. Okay. For second and first, what is equal, guys? Students? So this segment is already equal. For second graph and first graph, are there any segments that is common?
BCD.
First and second, first is this. Second is this. So common segment is this, right?
Yes.
G, yeah, D, F, G. So the other segment should be equal because they are not common. Then only the area will be equal, right? You get the idea?
Yes, sir.
So this segment should be equal to this segment. That's it. BCD should be equal to DEF. And you know the other condition. Okay, ABD should be equal to DFG. So if you got the idea, it's enough. Okay, I don't have to go more than that. Second. Ball is struck freely to a flow of height 1 meter. Its speed is reduced by 25% at each bounce. What would be the height the ball reaches after 3 bounces? Yes. So speed decreases by 25% means 1/4 is lost. So what is retained?
3/4.
Yes, 3/4. 3/4 will be the subsequent velocity after the collision with the ground. For example, initial velocity V, when collide, it will come with 3/4 V and reach a smaller height actually. And then when it hits the ground again, what would be the velocity? It will be 3/4 V.
into 3/4.
No, 3/4. When it reaches the ground again, after the collision only, it will reduce. You understand?
Yes.
I'll show you step by step. So now it starts here. It hits the ground with V. What will it return with? 3V by 4. And then it will go up, comes to rest. And then again it will hit the ground with 3 by 4V. And then again when it comes up, it's 3/4 of 3 by 4. So therefore, 3 by 4 to the squared V. So that's this after the second collision. So similar thing will happen after the third collision. What is the velocity after third collision? Another 3/4, right? So thrice right into V. Got it? Do you understand?
Yes.
Yeah. Now, what will be the height? If the initial height is the question, 1 meter, what is the final height it would reach after 3 collision? You have to find the height now. How do you do that? It's actually an energy equation. You know, if the initial velocity is this, what is the maximum height it would go, right? Anybody knows any shortcuts? It's called v squared over 2g, right? So initial kinetic energy, half mv squared, is the final potential energy. You can chop the m's, and then h will be equal to v squared over 2g. G is a constant, 2 is a constant. So therefore, h is directly proportional to v squared. Okay, you have to write this in your explanation note. Then only you can train yourself for the future. Okay. So now initial 1 meter is directly proportional to the initial hitting velocity, which we took it as v squared. Final height is directly proportional to what is the velocity now? 3 by 4 cube v. All together squared. Squared is for the velocity. Okay. And then if you solve it, yeah, what is the answer? Fourth one. Yes. Any questions? Okay. Next question. I'd like to explain this in whiteboard. Okay. We will switch to whiteboard now. Rest of the questions. You have to give me 5 minutes. Is the board clear for you?
Yes, sir.
Yes.
All right. So I will erase. Very difficult to erase it. Okay, can one of you read the next question? 33rd. Question number 33. Figure shows displacement time graphs for the motions of two cars with respect to lamp. So here the reference point is the lamp. Lamp post, the side of the road. Consider the displacement to right side of the lamp as positive. The student has made following statements regarding the motion of cars relevant to the points P, Q, and R. Okay. So point P, Q, and R are in the graph. This is how you see. So this is basically for part 1, and this is for part 2. Okay. The points are P, Q, and R. Okay. So you can see that car 1 starts its displacement from negative side, which means right side is the positive dimension. So it is starting from the left side, and the displacement reduces, means it is traveling towards the lamp. It reaches the lamp, and then it travels in the right side of the lamp. Okay, so for example, it is the road, it's coming from, this is the lamp. Okay, this is the lamp, it's coming from the left side, and going to the right side. Similarly, car 2 starts from the positive side, right side. So 1, 2, starting decreasing. It reaches the lamp and then goes in the negative direction. Means comes to the left side. So this is what happening. Okay, you know, it's very shocking that for some of the students, this revealed that they have never understood the displacement time graph correctly. They never understood because they didn't answer this question correctly. So never ever underestimate basic theories. Okay. Now first, relevant to P. First about the point P. The car 1 is coming from left. Process car 2. The cars are crossing, means they have to be in the same displacement. Then only they can cross. Otherwise, they can't cross. Crossing happens when you come to the same point. When P is crossing, sorry, at point P, car is crossing the lamp. But at the same time, car 2 has a displacement, means it is away from the lamp. So how can they cross? They can't cross. Okay. Okay. Then B. Relevant to the point Q, both cars are moving towards the lamp post and cross each other. Is that possible? They both moving towards the lamp and crossing. Is that possible in any universe? I don't think so. They're starting from opposite sides. Both should move towards the lamp and crossing. Not possible. They should be in opposite sides of the lamp. So crossing will never happen when they are moving towards the lamp. Okay, one should be moving away from the lamp. That is what exactly happening in Q. Are they meeting? Are they meeting?
No.
Do the cars cross?
No, sir.
They cross, right? They are coming to the same point at Q. They cross. But you can see they have one is having a positive gradient, one is having a negative gradient, which means one is moving towards the lamp and the other one is moving away from the lamp. The crossing happens somewhere here, right side, because it's a positive displacement at that point. So that means it's happening in the right side of the lamp, but car 2 will be moving towards the lamp. Now one will be moving away from the lamp. So they both can't move towards the lamp. That's impossible. So that statement is also false. C, relevant to R, R2 coming from the right passes the lamp post. R2 is coming from the right because it's initial positive displacement. When it crosses the lamp, yes. When it crosses the lamp only, the displacement is 0. So therefore, the correct answer is C only. Okay. 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 34. Figure shows velocity diagram for the object for an object moving along a straight line. What is the average velocity? So the equation for average velocity is the total displacement divided by time. So you have to calculate the area under the graph total and then you divide it by the total time. So that will give you the average velocity. So I don't have to do anything. Okay. The 35th one we will do when we discuss the waves. 36th one I have already explained that to you. 37. The ball is thrown vertically upwards from the ground. The time duration between the two instances, the ball passes the point at height 25 meters on its path from the ground is 4 seconds. So do you understand the meaning of what they say? This is the ground. So the ball is thrown from here. You go to a particular vertical height and will come to rest momentarily and then it will come back like this. So it crosses a point that is at height 25 from the ground. Let's say this point. Time taken for that crossing means going up and coming down. So this time period is 4 seconds. Now you understand the importance of past papers. I explained in the past paper question, very old one, right? Here you might have used it. Here the question is, what is the initial velocity of the ball? Yeah, there are many ways to do this, but can you come up with a way using the idea that I told you today? Anybody? Initial velocity is the question. Yeah. If you find the velocity here, it's easier for you to find the initial velocity. How can you find the velocity?
20 meters second.
Yeah, that's 20 meters. I told you. If this motion takes 4 seconds. Upward motion it would be 2 seconds. Downward motion it should be 2 seconds. So from the highest point to reach this point, if this is 2 seconds, the velocity here will be 20 ms minus 1. That will be the same velocity here, but in the upward direction. So you can use the here to here to find the initial velocity because final is equal to initial. From here to here you can use. Okay? So I will use from here to here because gravitational acceleration is also g downwards positive. And if I find the velocity when it hits the ground, I can find the velocity when it started the motion. So here for me, from here to here, initial velocity is 20 known. Distance is 25 known. Acceleration is known. You have to find the final velocity. What is the equation? V square is equal to u square plus 2as, right? V square is the question. U square is 20 square plus 2. A is 10, S is 25. So if you find out, it's the correct answer. It's 400. Is it? Yeah. 500, 400, 900. Square root of 900 is 30. Is that difficult? Not at all. But it is a 48th question. Actually, the last 10 questions of your paper are supposed to be difficult. So this is the difficult one they give you. You quickly note it down, okay? So these don't need explanation. That you have just find out and take it for this. Question number 38. A figure shows a displacement time graph for two objects P and Q moving along a straight line. Consider the following statements. A. Both objects have velocities in the same direction. So when you are discussing the direction of the velocities, you have to look at the angle. What? If you look at the angle that P makes with x-axis, it is an acute angle. If you look at the angle that Q makes with x-axis, acute angle. So both have same signs, plus signs for the gradient. So therefore, they will have same directions of the velocities. Okay. Both the objects have velocities in the same direction. That is true. Second one, velocities of both objects increase in time. What do you say?
False.
That is false, exactly. Here you can see the angle increases for P, gradient increases. But for Q, the gradient decreases. You can see the angle decreasing. So therefore, the velocity of P increases with time, whereas velocity of Q decreases with time. So the statement is false. A is true, B is false. C, both of these have same velocity at the crossing point of the two graphs. This is the point where they meet. Obviously, they have different gradients, right? If they are having same velocity, then the graph should be parallel to each other. Here you obviously see an angle between them, so it cannot be equal. So A is only correct. When you really understand the meaning of gradient, directions, signs, you can easily answer any question. Course 39th one is a center of gravity question. We can't do it now. If we go back, okay, first of all, do you have any questions that are doubtful among the ones that I didn't discuss?
Question number 17.
17.
17.
That's a good question. So in which of the velocity time graph shown below would the average velocity over the entire period T1 to T2 would be equal to the average of the two velocities at ends of AB of the interval. So when you calculate the value of VA plus VB divided by 2, just directly grossly calculating this average of the two ends will give you the actual average velocity. Actual average velocity is the average equation is actually displacement total divided by time. Total time. So this question you actually answer with experience. If you just add the final and initial velocity and divide it by 2, will give you the average velocity in uniform acceleration. Nowhere else. For example, see here. Q, V. Okay. So what is the displacement total? Total displacement is sum of the parallel sides divided by 2 into time total. V average is S total V plus U over 2 into time divided by total time. Total displacement is the equation divided by time. So you can chop these. So what do you see? V average is equal to V plus U divided by 2. So just adding and dividing by 2. Adding the velocities at two ends and dividing it by 2 gives you the average velocity. That's only possible in this linear graph. None of the others. Okay. Got it?
Yes.
Do you know of any other instance where you can do this? Sum of the final and initial velocities. There's another instance where you can do this. That is, there's a motion starting from t is equal to 0 to t is equal to t, and at the point you have t is equal to t half also. During the first half of motion, if it is v1 velocity, and during the second half of the motion, it's v2 velocity. The average would be v1 plus v2 divided by 2. Okay. In this instance also, Say like this, v1 plus v2 divided by 2 will give you the average velocity. Can you find the velocity in this instance? Average velocity. Yeah? We will see here. Total is S. This is S by 2. This is S by 2. Which start at t is equal to 0 and finishing at t is equal to t. First half of the distance, here I said first half of the time, there is v1 velocity. But here the first half of the distance is v1, second half of the distance is v2 velocity. Throughout this is the velocity. Throughout this is the velocity. Now, what is this? Can you derive a formula for average velocity in terms of v1 and v2? I'll tell you the question again. An object travels half of the distance with uniform velocity v1, the second half of the distance with uniform velocity v2. What is the average velocity? If you want, you can do it as a form, or just send me through WhatsApp. I'll correct you. It should be v1, v2 divided by v1 plus v2, I guess. We don't have time to explain. Just there an equation for total time. And just divide it by total distance. Divide the total distance by total time. Alright. I will discuss some of the statement questions. See. Go to the front page. Sorry, the first page. Second question, see the second question. Consider the following statements made about motion of a particle. First, velocity of a particle can be reversed without changing the direction of the acceleration. Is that true?
True.
Yes. So that's what you see in free fall. You throw and the velocity direction is changed. Initially upwards, then downwards. I mean like this. Velocity time graph will be like this. Whereas acceleration time graph will be like this. Here the acceleration doesn't change the direction, but the velocity does. Same for the collision. Okay. B, when the particle is projected vertically downwards with a very large velocity. So this is the equation, statement I was referring to. It will exceed the acceleration due to gravity. No. Once you release, the only force is mg. The highest possible acceleration is g. Nothing more than that. It can be lower than that because of the air resistance, but still that is the highest possible velocity. See, acceleration of a particle is 0. It must necessarily be at rest. Come on, uniform velocity is possible, right? Question 4. Question number 4. Now, the figure shows velocity time graph for a particle which starts from rest and moves along x direction. According to this graph, first one, a particle comes to rest only at time t is equal to t3. It is at rest in what points? It's at rest at 0. It's at rest at, 0 velocity is rest. Yeah, T2, T3, 3 instances. No? B. Particle returns to the original position at time t is equal to T3. That's false. Because the positive displacement is greater than the negative displacement. So, resultant positive displacement will be there. There is no returning to the original point. C. Particle accelerates only during the time t0 to t1. Acceleration means increase of velocity. So that happens from 0 to t1, and in the opposite direction, it happens from t2 to graph is like this now. From here to here also it is acceleration. But in the opposite direction. But still you call it acceleration. Still acceleration. Okay. Fifth question. Object dropped from height h bounces back from the floor to height h by which of the following velocity time graphs best represents the motion of the object? So here you know h by 2, so there is definitely energy loss. It's not the elastic collider. So during the first half, it should reach a very high velocity, and then it will return with a smaller velocity. And I told you these two should be parallel. If you want to draw more, you can go here, like that. Okay. Now enough of questions, right? Now you are ready for the model exam. Do you have any questions? Oh, somebody has asked which questions I am discussing. I sent that file to the group. Sorry, I didn't resend. Some of you joined today. I'll just send it to you. It's just Pesur book. I will recommend you to buy Pesur book. Okay. Yeah. All right. No questions. So get ready for an exam, right? Thank you.